Hi everyone, this is Ramalinga Prasad Kuppa. Welcome to my channel, Pharma World. Today's topic is Analytical Balances as per USP Chapter 41. Analytical balance is essential piece of equipment for weighing accurately for the analysis. The analytical balances are mostly used for milligram level to gram level amounts. Entire analysis and the correct and true outcome of the result totally depends on accuracy of the weigh. In this video, we will focus on several aspects of handling of analytical balance, its care, qualification, and calibration. Read sections USP 41 along with 1251 and EP 217 for some more intricate information. Analytical balances that are used in laboratories are very sensitive and are widely used for weighing milligrams to grams range of materials. As explained in the previous slide, the sample weights are in very low range. As you can see, lower the range of weighing, higher the accuracy required. A small error can result in huge difference in the outcome. The balancer should be installed, qualified, calibrated routinely for getting accurate results always. As a rule, any equipment used in the manufacturing should be qualified for its performance as required. So, the analytical balance must be installed properly as per requirements of installation, qualified for its operating parameters and performance for the entire range of operation. Routinely, the balance should be calibrated for the entire usage range. Such sensitive balances should be protected from excessive disturbing air currents and potential exposure to vapors of acid or other corrosive liquids or solvents. Strong excessive winds can disturb the accurate functioning of the balance. Exposure to acid vapors or other corrosive liquids or solvent vapors can rust the balance adversely. Let us see the requirement. Whenever there is a requirement to weigh accurately, the balance must be calibrated for accuracy and repeatability in the range the weight is taken. Requirement to weigh accurately 1 gram is different from requirement to weigh 1.0 or 1.00 gram. For 1 gram, you can weigh any amount between zero point 0.9 and 1.4 grams, whereas for 1.0 grams, the limit would be narrower between 0.95 and 1.04 grams, and it will be still narrower at 0.995 and 1.004 for a value of 1.00 grams. So the balance used should be able to weigh accordingly. As per USP 41 requirement, it should be calibrated for accuracy and repeatability. Let us see what they mean. Accuracy is defined as closeness to the result to true value. For example, for a true weight of 1.00 grams, the balance should be capable of showing the value closer to that value. The value should be within 0.10%. That means it should be able to show between 0.999 and 1.001 grams. Repeatability is defined as closeness of the agreement between the results of successive measurements. For repeatability conformance, it is done by weighing a comfortable weight within the range for not less than 10 times. Calculate the standard deviation. Repeatability is satisfactory if the standard deviation multiplied by 2 and divided by the smallest net weight on that balance does not exceed 0.10%. So you should weigh only that smallest weight on that balance. where the repeatability does not go beyond 0.10%. This is important. Other parameters, eccentricity, sensitivity, and linearity, are also included many times for routine calibration. Eccentricity is also called as corner load error. For this parameter, the selected weight is placed in the center of the pan and the displayed weight is recorded. Then it is placed in one corner of the pan and displayed weight is recorded. Similarly, the weight is checked in all other three corners. With a round weighing pan, the protocol is same. The aim is to compare the difference between the extremities of the weighing pan to the center. The sensitivity of the balance is usually expressed in terms of the amount of weight which will cause the pointer to deflect or move 1/4 of a division on the index scale. Sensitivity is sometimes also expressed in terms of the change in the equilibrium point caused by 1 milligram. Linearity is tested by placing known weights on the balance from near zero to full capacity. It will be linear because if you graphed ideal results, you should get a straight line. Linearity is defined as the ability of a scale or balance to show the correct value throughout the weighing range. Let us see the requirements for qualifying a balance. The balance should be installed on a solid, level, non-magnetic surface. The balance should be installed in such a way that it is free from external vibrations on a sturdy, smooth and hard surface leveled using a level indicator. Most of the balances are provided with an inbuilt spirit level to level the balance. The surface should also be non-magnetic. A smooth concrete mortar can provide excellent non-magnetic surface. Also, it is important to keep the balance away from strong currents of any magnetic energy. The balance should preferably located in a temperature and humidity controlled room. It is also recommended to install in such controlled atmosphere. The room where the balance is located should have consistent power supply. The balance should be supplied with stable power supply to avoid any spikes in power supply. Such spikes can have adverse impact on the operation of the balance. The location should be free from potential air draft, away from hot air ovens, muffle furnaces, cooling fans, air conditioning ducts, etc. All these equipment can disturb the function of the balance adversely. So it is very important to keep all these away from the vicinity of the balance. The balance should be switched on as first step and allowed to equilibrate. After successful installation and qualification, turn on the equipment and allow it to equilibrate. All the mechanical parts and ancillary equipment should be checked for correct operation. As next step, the operation of doors, pan and other electronic connections should be checked for proper functioning. Stable indication, tear function, print function, etc. should be checked on the display screen. Stable display, tear function, print function also should be checked for proper working. The display should be stable within few seconds. For printer, it is recommended to use an ink printer and not a thermal printer. Information on thermal printer does not last longer. After few days, the print data disappears from the printed slip. Initial calibration should be carried out by internally built weights or external weights. Most of the sensitive analytical balances have built-in calibration. This can be reconfirmed by external calibrated weights. While calibrating the external standards, care should be taken to avoid accumulation of fine dust over smaller weights that will change the standard weight adversely. You must use suitable forceps. All the standard weights should be stored well in a suitable container. You should also avoid excessive handling like hitting against hard surface or dropping on the floor. Following should be checked during performance qualification. Sensitivity, the change being expressed in scale divisions per milligram. Sensitivity is change in the display value from 0 divided by the load on the balance. For example, if 1.00 gram is considered as load, the display value should also show 1.000. Allowed tolerance is not more than 0.05%. That means the value should be between 0.9995 and 1.0005. Linearity is the linear relationship between a load and the indicated weight value. Linearity is the measure of ability to follow linear relationship between the load and displayed weight value. It is established by weighing in 3 points or 6 points. Here also the allowed tolerance is not more than 0.05%. Eccentricity, this is performed in the center of gravity and the four quadrants. Eccentricity is a measure that whatever the load is placed on the pan, it should be within 0.05% tolerance from the center point to all four corners of the balance. Repeatability is its ability to display identical measurement values for the repeated weighing of same object under the same conditions. Repeatability should be carried out as per the prescription of calibration by taking 10 consecutive weights. Let us see the types of standard weights. There are variety of standard weights available for calibration of analytical balances. So, depending upon the operating range, the weight class is selected. For high precision balances, E1 or E2 class weights are used. High precision balances that are used for very low weights like 2 milligrams to 5 milligrams should be calibrated with this type of classes. For E1 class, the tolerance will be 0.01 mg for 1 gram weight. For E2, it will be 0.03 mg. As you can see, the tolerance for E1 type is 0.01 mg, and for E2 class it is slightly higher at 0.03 mg. Class F is primarily used for commercial weighing devices. For F1 class, the tolerance will be 0.1 mg and it is 0.3 mg for F2 class. So for F1 and F2 class, the tolerance is 10 times less relaxed when compared with the E class weights. Let us see some of the important points to note during weighing. While weighing electrostatic materials, there is a possibility of attraction or repulsion to the weighing container or balance. For such materials, a built-in anti-static device should be available. So, unless there is a built-in anti-static device, there is a possibility of erroneous weight being transferred. For volatile liquid weighing, a gas-tight enclosure of small diameter is recommended. Unless this type of gas-tight enclosure is used, it is difficult to get a stable display of weight on the balance because the material keeps evaporating, making the display unstable for quite longer. Warm or cool materials should be equilibrated to ambient temperature before taking for weighing. This is important. Temperature variation can result erroneous weights being transferred. Hygroscopic materials should be weighed promptly or placed in gas-tight containers. External moisture can cause variations in weight unless you follow the procedure this way. Aseptic or biohazardous materials should be weighed in a clean bench with biosafety cabinet, isolator or similar containment device. You need a separate cabin for such operations. Many salts are corrosive. Such materials should be handled with more care to avoid spillage on pan or elsewhere in the balance. Sealed containers such as weighing bottles or syringes should be used to avoid any spillage of material. This is very important. Many salts are corrosive and can damage the pan and the other parts of the balance if not handled properly and carefully. Many salts are used for preparation of buffers or other solutions. Never weigh in on an open butter paper. There is a definite possibility of spillage on the weighing pan or gaps in the doors of the balance and surrounding gaps around the weighing pan. So always use sealed or promptly closed containers, preferably the weighing bottles. In case of any accidental spillage, requalification of balance may be necessary. So, depending upon the seriousness of the spillage, it may be necessary to requalify the balance. Other important points. When once the high precision balance is installed and qualified, it should never be moved from that place. This is important. You should never move the balance from the place where it was originally installed and qualified fully. If there is any necessity to relocate, the internal weights should be locked, relocated in new location and qualified and calibrated once again. This should be done by the skilled technician of the supplier of the balance and not by any unauthorized and unskilled analyst. All surroundings of the balance should be clean and should avoid accumulation of fine dust. Suitable fine, smooth brushes should be used after each use. Never leave all the doors of the balance open when not in use. Do not throw paper garbage around the balance. Safely drop all the used weighment butter papers into the dustbin. Keep the surroundings and the inside of the balance clean always. I hope that the information on operation and care of the balances is understood well. Check your current SOP on operation of balances has all these salient features including a provision to weigh different types of materials with different characteristics. Thanks for watching. For more videos, please do subscribe, like and share. Thank you.